for any of you absent people that didn't watch the video, maybe you want to use the time in class to get caught up on yesterday's. You decide, okay? But everybody focused, paying attention. We're doing the ones that I didn't cross out just on this page. Then you'll have a lot of time to work on the homework, but I'll start with you. We are on day 2 of 3.10. Tomorrow is day 3 of 3.10. Monday, we're going to have a homework check along with doing 2 days of 3.11. 2 days of test review, test next Friday. Okay? But I keep saying that, but I wanted to remind you guys. And what we're doing, continuing today, is trig equations. All right? So trig equations are just what they sound like. They're equations, meaning they have an equal sign in it. There's a variable somewhere in there, an x usually, but it could be a theta. You see theta sometimes. You can always change theta to an x or x to a theta. It's just a variable. It doesn't matter. And you'll see, because it's a trig equation, you'll see a trig function in there. When I say trig function, I mean sine, cosine, or tangent. Like literally those words are in the problem, okay? But so this assignment is really testing 2 major skills. How are you at factoring and solving equations? And how are you with the unit circle? It's all wrapped up in one lovely assignment, okay? So let's go over the types of problems you'll see. So first of all, given a problem, you want to just take a second and look at what you have. So this is a sine equation. So sine is the trig function. There's a variable x. Your goal, your first goal of 2, is to get the word sine and x by itself on one side, okay? And you're just using your regular old boring algebra skills to isolate the sine and the x. If looking at this equation is confusing to you because of the word, you can take the word out. So if you look, right away you might be thinking, is that a typo? That sine squared x is the same as like x squared. It's just in trig they put the squared on the word instead of the x, okay? But you could think of that as this, 4x squared minus 1 equals 0, okay? If I just took the word out and put the squared on the x, how would I solve that? To get x by itself, I would add 1, right? Divide by 4 and do the square root of both sides. So that's what I'm going to do. And if you want to write it like this first and then slip the word sine in at the end, you could do that. And that's what I'll do on another problem just to show you. But on this one, I'm just going to go ahead and move it in. So I would add 1 to both sides. And then I would divide by 4. And remember, I need sine and x by itself. Right now, I have a squared on that side. So it's just the same idea. If I were at this step right here, what would I do next? Take the square root, right? And I'm going to do that right now. I'm going to take the square root of both sides. And we're doing weird stuff with words, right? I'm taking the square root of a word. It's really just the number, though. So the square root of sine squared x is just sine x. That was our goal, goal number 1, to get that by itself. And over here, I would have a plus or minus. Don't forget, when you take the square root of something, you have 2 solutions. The square root of 1 is 1. The square root of 4 is 2. So that's goal number 1. Get the trig function and its variable by itself on one side. But that's still not solving it. Remember, solving an equation means isolate the x. X equals whatever, okay? That does not say x equals. It says sine x. X is a theta. X is an angle. So just like yesterday, what you're asking yourself here is what angle on the unit circle, that's what that means, just on the unit circle, do we have a sine value of 1/2? What denominator is that, guys? Where we have 1/2 as the sine value. That's what it's asking. Where does that happen? All of my 6's. You've got to know that without looking at your unit circle, okay? And guess what? We don't even have to use all students take calculus like yesterday. You will at different problems, you'll see. But look at this one. This one's almost easier. It's asking for the positives and the negatives. Well, guess what? That's all 4 quadrants. We're going to have 4 solutions because there's 2 positives and 2 negatives on the unit circle at every 6, 4, and 3. So my final answer in any order, it's going to be all of my denominators of 6. Okay? And again, any order. You'll see them all different order. You just have to know what your answer is. So quadrant 1 would be pi over 6, right? In quadrant 2, we subtract 1 from our denominator. In quadrant 3, we add 1 to our denominator. And in quadrant 4, at 5, we go to 7, 11 would be my last one. So those 4 angles are the actual x values. Okay. Let's do another one. Now, I showed a lot of work here. You don't have to. Okay, I'll show you how you can make it a little simpler or show no work. I mean, I'm hoping you guys can look at this and say, okay, I need to get tan and x by itself. I'm going to add 1 and divide by 3, right? I'm going to add 1 and divide by 3. So I would have tan squared x equals 1/3. If that was too many steps at once for you, show all the work like I did here, okay? But I added 1 divided by 3. Then I'm going to take the square root of both sides, right? How do I know to do that? Because they're just squared with my trig function. So I get tan x on this side equals plus or minus. The square root of 1 is 1, but the square root of 3 is a decimal. Now remember, every answer we get here should be something that's familiar to us on the unit circle. There's nothing on the unit circle that says this. But we saw this yesterday. We've seen it a few times. Technically, you are always allowed to leave a radical in the denominator in this class. Okay? In up through Algebra 2, we would always have to do what we call rationalizing the denominator to get the radical out of the denominator. In calculus, pre-calc and up, you can leave it there. But remember, a lot of times, especially in a multiple choice or in a situation like this, it would make more sense to get that radical out of the denominator. So I did this with you yesterday, so I'm just going to show you again. But after this, I would just memorize what this equals. So rationalizing the denominator means multiplying the denominator by itself. That's exactly what you see. What you do to the denominator, you have to do to the numerator. Okay? So we have a 1 on the outside. I don't need to write that. And the square root of 3. And the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So you'll see this a lot. 1 over the square root of 3. Leave it like that and know that it equals this, or change it to that. It doesn't matter. But you don't have to do the work every time. That's a really common one you'll see all the time. But if you forget, at least you know how to do it, okay? So think about your tan. What angle has a tan value of square root of 3 over 3? 6 again, right? And it's the pluses and the minuses because of the square root. So it's the same answer as we just had. I wish the notes had a different one, but it is what it is, fine. So it's pi over 6 and 5 pi over 6 and 7 pi over 6 and 11 pi over 6. It's all 4. Okay, so remembering your tan trick, denominators of 6 are the square root of 3 over 3. Okay? So those, that method that we just did was called like the square root method. Anytime you're missing the b value of a quadratic, right? This is ax squared and this is the c, the constant. Anytime you're missing the b value, it should stand out to you. Just get everything to the other side, square root, and then go from there. Okay, so when we get to the homework, it's basically 3 types. I wrote next to it square root or something just to help you know how to start it, but I don't feel like that's been a struggle for you guys overall. All right, let's look at the next one. Solving quadratics by factoring. This is a quadratic trinomial. What you could rewrite this as, and this is what I would do here, I would take out the word sign. Anywhere I see sign, I would take it out. And I would write it algebraically. I would need to put the squared on the x. Because this is a chart problem with the extra steps, because there's a 2 in front. So even though it's completely doable, you're allowed to keep sign squared and sign in there. It's a lot of writing. It takes up a lot of room to keep writing sign over and over. So in these types of problems, I like to take the sign out and I'll sneak it back in at the end. I'll show you how to do that. But let's just use our algebra skills first to factor this, because that's what we're doing. We're factoring, okay? So I recognize this as a quadratic trinomial, A, B, and C. So this is a chart. These are the chart problems, okay? Whether you use a chart, whether you write a chart, that's what I call them. You guys know that. So I'm going to ask myself, what two numbers multiply to get A times C? So 2 times negative 1, that's negative 2. And the B value is negative 1, right? Well, there's only 2 numbers that multiply to get 2. 1 times 2, right? There's nothing else. So it's got to be 1 and 2. And then you play with the signs. The 2 would be negative, right? And because of this 2, be careful. I still, at this level, see people writing x plus 1, x minus 2. It's not x plus 1 and x minus 2 unless the 2 weren't there. Then you could go right to the factor. Whenever there's a leading coefficient greater than 1, like this, we do that, bring down the outside 2 terms and split the middle. We split the middle into these two numbers, putting an x on them. And it doesn't matter if you put the 1 first or the negative 2 first. I like putting the negative first. But either way, don't forget that they get an x. Because look, negative 2x plus x, the two numbers I write here should equal what's right above it. That's why we're splitting it into those two. So if you leave the x off, it's not going to be negative 1x. And now we group 2 and 2. GCF, factor out the 2x. And remember, there's a plus sign right there. You have to put something right here. Something has to go there. Even if it's just a 1, you have to put something there. Okay? And sometimes it is a 1. No big deal. And now we're ready to write our factored algebraic version. 2x plus 1, right? And x minus 1. Okay, so if we were back in polynomials and I told you to factor, you'd be done. If we were back in polynomials and I said solve after you factor, you'd set these equal to 0 and solve, and you'd be done. But remember, we were just tricking ourselves for a minute and making it look like it was a polynomial, not a trigonometric equation. That's an mouthful. So here's where I'm going to sneak the sign back in. Where do you put it? It always goes in front of x. Okay, even if you have to push someone out of the way. Like I'm going to push that 2 out of the way to fit in x and set it equal to 0. Set that equal to 0. And I'm going to do the same thing for this one. That would be sine x equals 0. Remember goal number 1? We still haven't even reached goal number 1, which is to get sine x by itself on one side. What'd I do? Oh, sorry. So this one's good. This one's got sine and x on one side together. This one I would have to do a little bit of work, right? Subtract 1 and divide by 2. Subtract 1, divide by 2. Okay? And now I'm going to answer these. Where on the unit circle is sine 1/2? 6's again. It's not always going to be 6. But it's not all of them, right? Because it's just the negatives. So there's going to be 2. And where they are, so in this case, for me, I like to use all students take calculus. As long as you can figure it out, I don't care what method you use. But where is sine negative? Well, sine is positive in 1 and 2, so we're only going to put quadrants 3 and 4. So quadrant 3, we add 1, quadrant 4, 5, 7, 11. Okay. And when I see a sine or a cosine that has a 0, a 1, or a negative 1, I know it's a quadrantal. And since you're about to do a chunk of problems where you have to use the unit circle, I told you guys I like to have this on my paper somewhere. You'll see me write it again when we get to the homework. But it's just nice to have that, so every single time I get a 0, a 1, or a negative 1, I don't have to rewrite it or think about it. I just like to write that at the top of somewhere in my work. Maybe I'll even write this so I don't have to write it every time. I can just glance at it. Just a little bit of work ahead of time saves me a lot of work throughout the process. Anyway, where is sine 0? That would be here and here, right? That's where sine is 0. So we call those angles 0 or 0 pi, either one, right? 0 or 0 pi, and then just pi. So guys, all 4 of the, wait, I did that wrong. I did this wrong. What's this? I left off something. Sine x minus 1. Nobody caught it? Thank you, May. Yeah, yell at me, guys. Yell at me. So, guys, right here, it wasn't just sine x equals, it was sine x minus 1. Let me just fix it. I'm so sorry. Don't be mad at me. Sine x minus 1. So when you add 1 to the other side, it's actually sine x is 1. Where is sine 1, guys? Right here at the top. Sorry about that. So these 3 are our answers. Okay, do you guys get what I just did? I feel like I went too fast over what I just messed up on. Right there, I should have had sine x minus 1 equals 0. I left off the, so add 1. Okay, so that's where I messed up. Right, and I just want to remind you, for those of you that were here yesterday, we had a similar problem to this, where we got a pi over 2 in our answer, and we crossed out and said it was extraneous. The reason why this one's not extraneous is because tan is not involved. There's no tan in here. Remember, anytime you're working with tan, you got to be on your toes. And one of those things is, if tan is in an equation, you'll never get a pi over 2 or a 3 pi over 2 as a solution. Sine is fine, a pi over 2, and cosine, but remember, at pi over 2 and 3 pi over 2, sine is undefined. You will never have a solution set that contains the word undefined. It doesn't make sense. There's an asymptote there. It's not a solution. It can't be. So we would have crossed that out if either one of these had been a tan, okay? So if you don't know what I'm talking about, that was something we did yesterday. All right, those are the worst. There are 2 in your homework. I'm going to do 1 with you, and you'll have 1 due on your own. So I didn't give you a ton of those to do, all right? Because they're a lot of work, but we need to know how to do them. Last one. Last equation. What I want you guys to notice about this equation right here is it's got sine and tan mixed together. Anytime you see sine and cosine together, sine and tan together, cosine, a mixture of more than one type, it's usually going to be this type of problem. I want to say always, but you know what happens if I say always, then there'll be some exceptions to the rule. So this is a GCF problem. What we want to do anytime we see this mixture is get them all on one side together, okay? So I have sine squared x, tan x. That's on the left side already. And I'm going to bring the 2 tan x to the other side by subtracting it. So anytime we factor, we want 0 on the other side. That's what I'm doing there. And guys, I want you to think of this. Let me compare it to algebra. If I gave you x squared y minus 2y. If I gave you that problem and I said factor it, you'd go, oh, this is a binomial, right? 1, 2. They have a y in common. If I take a y out, what's left over? You're just dividing this by y, dividing this by y. You'd have x squared minus 2. It's the same idea. What do these 2 have in common? Tan. They both have a tan. So that is what's going to go on the outside of my parentheses, tan x. Whatever's left over goes inside. If it helps you to show this step, go ahead. I'm dividing both of these by tan x, just like I divided both of these by y. Tan x cancel. All that's left is sine squared x. And minus, tans cancel, 2. So on these GCF problems, which are the mixed, get everybody on one side together, factor out what they have in common, and now you've been able to separate. We have tan x is one factor, sine squared x minus 2 is another, and we just set them each equal to 0 separately. Tan x equals 0, sine squared x minus 2 equals 0. This one's already got tan and x isolated, good to go. This one I would have to add 2 and take the square root, right? Sine squared x, add 2 to the other side. Still have a squared there, I would get rid of it. Sine x equals plus or minus the square root of 2. Let's just deal with this one right away. Where on the unit circle do we have a sine value of square root of 2? Nowhere. Doesn't exist. It's extraneous. It should be something you know. 1/2, square root of 3 over 2, square root of 2 over 2, negative 1, 1, or 0. Those are the only numbers in the whole unit circle. Right? And then where is tan 0? Well, guys, back to this little quadrantal picture. We've been talking about it the last couple of days, that tan is undefined at the top and the bottom, right? Undefined, undefined. It's 0 here and here. 0 over 1, 0 over negative 1, in both cases are 0. Tan is 0 at the first and the midway. So our x would be 0 or 0 pi and pi. Those would be the only two solutions. Okay? So you can see we're mixing a lot of your skills in one assignment. As I've been telling you, you know how to factor till the beginning of the year. It's never going to go away. Just deal with learning how to factor and knowing how to do it. That way you're annoyed with it, but you're not stressed about it. Okay? So let's go to the homework, and I'm going to do a couple different ones with you just to make sure you're good. On page 124, 1 through 12, C28, I'd like you to change your directions to, instead of including the 2 pi with a bracket, to make it a parentheses. Jaden, write this down. So here's the thing, guys. There's a whole debate in should we include 2 pi or not. I say no, because 0 and 2 pi are the same angle. It's like saying my solution is 4 and 4 over 1. Why would you list 4 and 4 over 1? I mean, they're the same thing. But there are some times where they say to include 2 pi. So anywhere you would have an answer of 0, you'd also include 2 pi, which doesn't make sense to me personally, so I don't like it, so I changed it. But we might see it again. But you should pay attention to that. So this work, in our homework, we are not going to include the 2 pi, just like we didn't in the notes. If you go back and look at all of our notes, we did not include 2 pi on the unit circle. Right? So let's do, Jaden, come on. Let's start with number 1. And when I put the key up, and I did put the key on Canvas, because a lot of people last period were saying they had a hard time seeing, so I put it on Canvas already. So when you get to the homework, if you want to pull it up on your computer, you can. So in this problem, we already have 0 on one side. Everything's on one side. So that's taken care of for us. So now you have to decide, is this a GCF? Is this a quadratic trinomial? Is this finding the square root? And the thing that tells us this is a GCF problem is that we have mixed trig functions in the same problem. Okay? So everybody's on one side together. What do they have in common? I think you guys would agree with me that it's cosine x. So I'm going to divide this one by cosine x and this one by cosine x. And whatever's left over goes in the parentheses. Cosine x divided by cosine x is what? 1. Okay. Just like 5 over 5 is 1, x over x is 1. Cosine x over cosine x is 1. Minus, these cosines cancel, and I'm left with 2 sine x. Guys, it's just the reverse of the distributive property. If you're questioning if you did it right, check it by distributing. You should get what's right above it in red. So I'm going to set each of these equal to that 0 separately and answer them as 2 separate equations, although the solutions of both are go into the same solution set. So I told you maybe you want to write this somewhere on your homework so you don't have to keep writing it. Cosine being 0, that's at the top and at the bottom, right? That's where cosine is 0. Right, Evan? Okay. I couldn't tell by the face of you. Right? Over here, subtract 1. Subtract 1. Divide by negative 2. And what angle has a sine value of 1/2? What would those denominators be? Yeah, 6 again? Gosh, yes. 6 again. And sine is positive in quadrants 1 and 2. 1 and 2. Pi. 5. So all 4 of these are the solution, okay? So if you look, they're written in no particular order. They can be mixed in together. All 4 are the solution, okay? So however you write them is fine, but all 4 are included, okay? When you look at the key, you'll see I wrote GCF for number 2. I wrote GCF for number 3. Number 4, guys, listen real quick. Number 4 is a calculator problem. They snuck one in here. This is what we did yesterday. So if you didn't watch yesterday's video, you're not going to know what I'm talking about. You can either simplify it just like you do on all the others by getting the trig function and the variable by itself, or guess what, guys? You don't have to do that, and I don't remember if we talked about it yesterday in this class. The calculator problems are really nice, because if you look, I could just type in the left side and the right side. This is y1, this is y2. I didn't even have to do any work. And remember, we change our window to 0 to 2 pi. And then we graph it, and we use intersection. So you can see I'll have an intersection there and an intersection there, and that's how I get my two solutions. Okay? So there's just one calculator problem on here. But I told you I was going to do one of the chart problems with you. So let's do number 5. I'm going to just go ahead and write it as a quadratic from the paper to the work here. So on these types where I have to do a chart, I like to get rid of the word in the beginning. So I just wrote it how it would look algebraically. The chart problem, 2 times -4 is -8. Middle number is -7. The only numbers that make an 8 are 1 and 8 or 2 and 4. 1 and 8, we can also somehow make a 7 out of it, right? A -7 specifically. Because of this 2, I'm going to bring down the outside 2 terms and split that middle. Into these 2 numbers, I like to put the negative first. Don't forget to put an X on both of them. And then you do your grouping. Okay, this step right here is GCF. What we're doing here is exactly what we did in number 1. Looking at a binomial, what do they have in common? Whatever's left goes in the parentheses. So these 2 have a 2 and an X in common. Right? I'm just dividing these both by 2x. What's left? X minus 4. Remember, even if it's just a 1, I have to put something there. You like it? Parentheses are the same. So algebraically, I'm factored. Now's the time where I'm going to slip. Let's look at the problem. Number 5 is cosine. So anywhere I see an x, I'm going to slip the word cosine right in front of it, okay? And set it equal to 0 and solve. So this one would be 2 cosine x plus 1 equals 0. That's that one. And this one would be cosine x minus 4. And we're still not done. We got to get cosine and x by itself. Jaden, come on, working. So I'm going to subtract 1, divide by 2. Show the work or don't show the work. That is your choice. That one had 4. Let's deal with that one. Where on the unit circle do we have a cosine value of 4? We don't. Extraneous. Where on the unit circle do we have a cosine value of -1/2? We know we have that. What's the denominator for cosine is 1/2? 3. And cosine is negative in here. Quadrant 2, I subtract 1 from my denominator. Quadrant 3, I add 1 to my denominator. Right. The entire key I can fit up here. I'll put the key up here. Guys, don't copy. Don't work on something else. Work on this. Try. Ask for help. Work together. Love it when you guys work together as long as you're working. But also the keys on Canvas.